Dear students, so in previous class we were discussing about the power series solution of second order differential equation. That is of the form y2 dash plus p of x y dash plus q of x into y equals 0. In that classes we are already discussed about the behavior of the solution of this differential equation. Ordinary points, singular points, regular singular points and irregular singular points. So we already stated that the behavior of the solution that only also depends upon the behaviors of this p of x and q of x, means the coefficients. And later x0 to be the consider x0. So x0 is said to be a singular point of this differential equation only when the coefficients p of x and q of x must be fails to be analytic at this point x0. So then it is said to be a regular singular if x minus x0 into p of x and x minus x0 whole square into q of x are analytic. If it is failed to be analytic at p of x and q of x, if it is x minus x0 into p of x and x minus x0 whole square into q of x are analytic, then x0 is said to be a regular singular point. Otherwise, it is said to be an irregular singular point. Okay. Then, if x equals 0, be a regular singular point, then we can assume sigma an x power m plus n be the solution of the differential equation. If x equals 0 be a regular singular point, then we can assume that the solution is of the form sigma an x power, let y equals sigma an x power m plus n be the solution. So here the exponent m, that may be negative, rational, irrational, whatever may be. So x0 to be the regular singular point only if x minus x0 into p of x and x minus x0 whole square into q of x are analytic. Okay. So let us consider an example. So consider a relation, consider a differential equation. Solve 2x square y2 dash. Consider the differential equation 2x square y2 dash plus x into 2x plus 1 y dash, x into 2x plus 1 y dash minus y equals 0. So, when you compare it with the standard equation, what about a p of x here? P of x equals coefficient of y dash, that is x into 2x plus 1 divided by 2x square. Let's again rewrite as it is 2x plus 1 divided by 2x. 1x cancelling each other. Okay. What about q of x? Q of x is minus 1 by 2x square. Clear? So clear. Both this p of x and q of x are failed to be analytic at x equals 0. At x equals 0, this p of x and q of x are not defined here. Means p of x and q of x are failed to be analytic at x equals 0. So this x equals 0 is a singular point. Why? Because at x equals 0, p of x and q of x are not defined. Since it is not defined, it is not analytic. So x equals 0 is a singular point. Then the next step is it a regular singular point? What about x minus 0 into or x minus x0 instead of x0? Here it is 0. X minus x0 means x minus 0 into p of x. Means what is x into p of x? Here x into p of x equals 2x plus 1 divided by 2. 1x cancelling each other. Again, x minus x0. Here x0 is 0. So x minus x0 whole square is simply x square. So x square into q of x equals minus 1 by 2. So here x minus x0 into or x minus 0 into p of x and x minus 0 whole square into q of x are both analytic at this x equals 0, then here we can conclude that x equals 0 be a regular singular point. It is a regular singular point. Since x equals 0 be a regular singular point or x naught be the regular singular point, we can just assume that y equals sigma an x power m plus n be the solution of this differential equation. Y equals sigma an x power m plus n be the solution of this differential equation. So what about y dash? Letter y. We can assume letter y equals sigma with respect to n an x power m plus n be the solution ranges from 0 to infinity. What about y dash here? So y dash equals sigma m plus n into an x power m plus n minus 1. Okay. What is y2 dash? Here y2 dash. y2 dash equals sigma, it is m plus n into m plus n minus 1 into an into x power m plus n minus 2. Okay. So you can substitute all of these values y dash, y dash and y2 dash in the given differential equation. So what you get? The equation 1. It becomes 2x square y2 dash. What you get? It is 2 into sigma m plus n minus 1 an into x power m plus n into x square m plus n minus 2 cancelling plus x into 2x plus 1 y dash, x into 2x plus 1 y dash, that is 2 into s, it is again 2x square into x into 2x plus 1 y dash minus y equals 0. So it is 2x square y dash means it is 2x square y dash. So it is again 2 into sigma, what is y dash? M plus n. So it is m plus n into an into x power m plus n minus 1 plus 2 means it is x power m plus n plus 1. Okay. What means plus xy dash? Plus xy dash means plus x in what is y dash? Again sigma m plus n into an x power m plus n minus 1 into x. Agree? Minus y minus sigma, what is y? An x power m plus n equals 0. Okay. Right. Now, so we can compare the coefficient of m plus n to 0. Comparing coefficient of from here. So here comparing coefficients of m plus n to 0. Y on right side it is 0. Okay. So what I get? It is 2 into, it is m plus n into m plus n minus 1 a plus m plus n an minus an equals 0. Okay. 2 into an, sorry. Now, before going to that one, there is a term. The term involving there is x power m plus n plus 1. So how to compare that one? Before going to this comparing, this can be again rearranged as, the second term is rearranged as 2 into, replace n by n minus 1. You can replace m by n plus n minus 1. Come on. One step is skipping there. So this gives 2 into the first term, that is sigma m plus n into whatever may be, this one, plus come to the second term. The second term involves the power of x is m plus n plus 1, but it can be rearranged as 2 into sigma, replace n by n minus 1. What you get? m plus n minus 1, a n minus 1, x power n plus n. That is the second term. Third term is same, fourth term is same. Okay. Now we can compare coefficient of m plus n, coefficient of x power n plus n to 0. What do you get? What is coefficient of x power n plus n in first term? It is 2 into m plus n into m plus n minus 1 plus, what about that in second term? Second term is this one, that is 2 into m plus n minus 1 into a n minus 1. What about that of third term? It is m plus n into a n. And what about that of fourth term? It is minus a n equals 0. Okay. So that means, come to the, or collecting the term involving a n, what do you get? Here it is also a n in first term. What do you get? 2 into m plus 1 into m plus n minus 1 a n. It is 2 into m plus n into m plus n minus 1 into a n plus n minus 1 minus of again m plus n minus 1 into a n plus 2 into m plus n minus 1 into a n minus 1 equals 0. Clear? Okay. So, when n equals 0, what do you get? Put n equals 0. Put n equals 0 here. In this equation, put n equals 0. What do you get? 2 into, here it is m, here it is m minus 1. So it is 2 m minus 1. Okay. Into, what is, here it is a naught. Then minus m minus 1. Minus m minus 1. Into a naught. So when n equals 0, listen, there is a term 2 into m minus 1 into a minus 1. That is meaningless. There is no a minus 1th term, or there is no minus 1th term. The term starts from 0th term. There is no term, no minus 1th term. There is no minus 1th term. So when n equals 0, we have 2 into m into m minus 1 minus m minus 1 into a naught equals 0. Okay. So, since a naught is strictly differs from 0, why? When a naught equals 0, so let me assume y equals sigma a n x power m plus n be the solution of the given differential equation with the a naught is differs from 0. Okay. With the a naught differs from 0. So, 2 into m into m minus 1 minus m minus 1 into a naught equals 0. Here a naught strictly differs from 0. So what you get? It is, if you take m minus 1 outside, what you get? It is m minus 1 minus m minus 1. So it is m minus 1 into 2m plus 1 a naught equals 0. Okay. 2m plus 1 into a naught equals 0. Here a naught differs from 0. Then means minus 1 into 2m plus 1 equals 0. So m minus 1 into 2m plus 1 equals 0. So that means there are two possibilities. Either m equals 1 or m equals minus 1 by 2. So listen, when n equals 0, you have m minus 1 into 2m plus 1 a naught equals 0. This equation is said to be an identical equation. This equation is said to be an identical equation. You can find out the identical equation in another way that we will discuss later. Okay, but here when n equals 0, the obtained equation, it is a minus 1 into 2m plus 1 a naught equals 0. That equation is said to be an identical equation. That is that's a crucial point. The term that's an important term, that is identical equation. So on solving this identical equation without a naught is 0, then we have m has two values, either m equals 1 or m equals minus 1 by 2. Clear? Now, by using these two values of this m, so here again after solving this one, we have m plus n minus 1 into, if you solving this one, so it is m plus, or simplify that one, m plus, not solving, simplify that one, it is m plus n minus 1 into 2m plus 2n plus 1 into an plus, here it is 2 into m plus n minus 1, 2 into m plus n minus 1, a n minus 1 equals 0. If you simplify this one, so you have m plus n minus 1, m plus n minus 1 into 2m plus 2n plus 1 into an plus 2 into m plus n minus 1, a n minus 1 equals 0. So consider that equation. Consider that one. So now give us this one. So in that equation, put n equals 0. Sorry, put n equals 1. What is it? When n equals, if you apply n equals 0, then you have the identical equation. After solving that identical equation, you have two values for this m. That is m equals 1 and m is minus 1 by 2. When n equals 1, 1 reduces to, what happens? M, when n equals 1, it is m into, come on, here 2m plus 3, m into 2m plus 3 into, when n equals 1, a1, plus when n equals 1, it is minus 2m, minus 2m into a0. m into 2m plus 3 a1 plus 2m a0 equals 0. Okay. When n equals 2, what happens? When n equals 2, what happens here? m plus 2 minus 1. That is m plus 1 into, here 2m plus 5. So it is 2m plus 5 into a2 equals, then m plus n, or here plus 2am naught equals 0. So a2 plus 2m into n minus 1, n equals 2. So it is 2 into m plus 1 into n equals 2, it is a1 equals 0. Okay. When n equals 3, so what is it? n equals 3, it is m plus 3 minus 1. So it is m plus 2. m plus 2 into 2m plus 2 into 3, 6 plus 7. So it is 2m plus 7 into a3 plus 2 into m plus 2, a2 equals 0. Okay, now consider these three equations. These three equations. When m equals 1, what happens here? When consider the solution of integral equations. When m equals 1, so this equation, equation 2 reduces to, what is it? 1 into 2 plus 3, 5. So 5a1 equals minus 2m a0. m equals 1 means minus 2a0. So that means, what is a1? a1 is minus 2 by 5 a0. So a1 is expressed in terms of a0. So when m equals 1, then a1 equals minus 2 by 5 a0. Now when m equals 1 in second equation, or in this equation, what I get? When m equals 1, so equals 2 into, when m equals 1, it is 2 into 2m plus 5. When m equals 1, it is 7. So 2 into 7 a0. Okay, 2 into 7 a2. So 2 into 7, that is 14 a2 equals minus 2 into m equals 1. So it is minus 4 a1. That means, what is a2? a2 equals minus 4 by 14 a1. Okay. So that means, what is a2? a2 equals minus 2 by 7 into, what is a1? Minus 2 by 5 a0. So it is, a2 is again expressed in terms of a0 like this. That is 4 by 7 into 5, that is 5 a0. Okay. When m equals 1 in next equation, here in equation 4, what I get? m plus 1, m plus 2, that is 3. 3 into 7, 2 plus 7, 9. 3 into 9. So it is 27. A3 equals minus 2 into M. 1 plus 2, 3. Minus 6. Minus 6 A0. Oh, sorry. Minus 6 A2. Okay. Minus 6 A2. 27 A3 equals minus 6 A2. That means what is A3? A3 equals minus 6 by 27 A2. Then again you can replace A2 by 4 by 35. Also A3 is expressed in terms of A0. So after getting these values, what is Y? Y equals sigma A n x power m plus n. Okay, when m equals 1, then the solution is, what are the solutions? When m equals 1, the solution sigma A n, come on, sigma n ranges from 0 to infinity A n x power m plus n. M plus n means n plus 1. Okay, when m equals 1. So, the solutions are y equals first term. First term a0 into x power, what is n? N is 1. a0 into x plus a1. What is a1? That is in terms of a0, minus 2 by 5 a0 into x square plus a2. What is a2? a2 is again in terms of a0, that is 4 by 35 a0 into x cube plus etc. So this is one of the solution. Then again, if you replace m by minus 2 here in equation 1, if you put m equals minus 1 by 2, then you have another number of equations. After solving that one, if you expressed one of these terms a1, a2, a3 etc. in terms of a0, then you have another solutions. Okay, so when x equals 0 be a singular point for the given differential equation, then x equals 0, here x equals 0, instead of the 0 then x naught. Then if x naught be the singular or regular singular point, then you can assume y equals sigma a n x power m plus n be the solution of the given differential equation. After supplies the values of y2 dash, y dash and y in the given differential equation, after equating the coefficient of either x power m plus n or x power m plus n minus 1, whatever may be, to equating to 0, then you have an equation which involves both the m and n. After putting n equals 0 in that equation, the obtained equation is said to be an identical equation, that is the crucial point. After solving that identical equation, you have 2 or 3 values for this m. Then putting that values of m in the modified equations, then you have 2 different solutions for this given second order differential equation. So this is the method, that is to find out the power series solution of a second order differential equation